In this video, I introduce a spectral norm regularization for deep machine learning. If a perturbation of input data causes a larger output variation, the deep convolutional neural network is not a stable model. The spectral norm regularization is a method to reduce sensitivity to the perturbation of the input. The flat loss is not sensitive to the perturbation of input x. Given a set of data x and y, the loss function L of a network is defined as the average of loss for each example, where F is a learning model that maps the input x0 to the output xl. The loss L for each example can be either cross entropy or square the L2 distance, and the theta as the model parameters. Our goal is to find the regularization in the loss function of a deep network model so that the model performance is insensitive to the perturbation of the input, namely L2 norm of f x plus c minus fx is small given a perturbation c. Given a perturbation c, the relative output variation of the model has an upper band. For example, this difference f x plus c minus fx smaller than this sigma, where sigma is a spectral norm of matrix W, which is the same as the largest singular value of the matrix W. If W has a small spectral norm, F will be insensitive to the perturbation C. Suppose that D is the activation function of the layer L. W is written as a product of D's and W's. If sigma D smaller or equal to 1 for all the L, using the inequality here, we have this spectrum norm sigma smaller than product of spectrum for each layer L. To obtain the upper band of spectral norm of W, we only need to minimize the spectral norm sigma in each network layer here. Adding the spectral norm sigma in the loss function, the minimum problem is written as here. This is the regular loss, and this is the spectral norm regularization, where lambda is the regularization factor, and L is number of the network layers. The spectral norm regularization is used to decrease the spectral norm of W in each network layer. To use the stochastic gradient descent to optimize the deep learning model, we need to compute gradient of this term with respect to weight WL here. This is sigma 1, U1 and V1 is parameters for the first layer of the network. U1 and V1 are the first left and the right singular vectors. Power iteration method is used to approximate U1, V1, and sigma 1. Starting from a random variable V, we compute U, V, sigma iteratively. From the initial V, we calculate U, and then now we from U to calculate V, and use U and V to calculate the sigma. For more details, please check with these references. Thank you. Bye.